Hello, welcome to the Computer Science channel. This is your instructor, John Noah. Today we're going to cover another very important topic in Java and any programming language, especially those that fall into the imperative and object-oriented paradigm. So let's create a project, File, New Project, and we're going to hit Next on Java Application. I'm going to call it Java 1, and then hyphen control structures. And I don't want to create a main class. Okay, so the topic today, as the name suggests, is control structures. We have to understand that when I talk about control structures or just control statements, different terms will be used, that we're talking about how do we modify or maintain the flow of control in a program. Now, for that to make sense, we might want to look at some of the examples we had previously in previous weeks. For example, in the input operations, we've got operator fun, which will open up. And right here, there's nothing really deviating from the flow of control here. Basically, when the program executes, it enters calls the entry point into memory, this main method, and then it goes to this line 13, initializes a variable to 5, initializes B to 10, initializes 7, C to 7, etc., etc. So everything goes in sequence. So the default control structure is that the code is executed in the order that it's written, or in the case of methods called, okay, like here when we have print line. But as you look at the instructions, you can see that they are called in order, exactly as written. That's called sequential control structure, or these are sequential statements. So that is the default. However, there's two other categories that we need to go over. I'm going to go over to our source packages here on our new project. I'm going to right-click, go to New Java Class, and we're going to call this Control Structure Fun. Get rid of some of these unnecessary comments here. Just a minute. Okay, so I'm going to import java.util.scanner because that will be used for getting user input. So once we've imported this java.util.scanner and we have our class here, we can create our public static void main, which will serve as the entry point of our application as usual. Little comment here, single line comment to remind us that that's the end of main. We could put one down here in class if we want to. Inside of main here, I'm going to introduce you to one of the other categories. So let's go over the three categories, and then we'll start zooming in and burrowing in a little bit deeper to understand the different aspects. So sequential is what I just showed you. That's the default. Everything's executed in sequence. Another category is called selection. So selection control structures. They're also called decision control structures in some scenarios. So these are used to select among or between different options, the selection control or decision control structures. And then we've got a third category called repetition or iteration, sometimes called iterative control structures, or most commonly they're just called loops. Okay, so that's the third category. So we got sequential, selection, and repetition. So sequential, selection, repetition. So it's good to memorize those three categories. Sequential doesn't really have any sub parts to it or sub structures that you can say are different types of sequential structures. We don't really usually subdivide that. But selection and repetition in Java each have three primary um, types of statements that would fall into those structure categories. So in the sequential category, okay, again, another thing to memorize it even if you don't understand it right now. Memorize the terms and the phrases, and then later on we fill in the gaps and it becomes more real. So three categories, and then the last two, selection and repetition, are actually divided into three statements each. So selection is divided into the three selection control statements: if else, and switch. If else, and switch are the three types of selection control statements. The repetition or iteration control statements, which are also called loops, are the while loop, the do while loop, and the for loop. So let's take a look at a little of the selection control, and then we'll start talking a little bit about the repetition control. So right here, I'm going to, let's say this. We'll say int age. We'll set it to 0 just to give it a value to start. And then what we're going to do is we're going to ask the user to input their age. So we could say system.out.println. Please enter your age. Then on the next line, they'll be expected to enter their age. So you could say we have to create a scanner to get that data. So let's say scanner keyboard equals new scanner based on the standard input object system.in. Because remember from our last lesson, system.in, we said is the standard input object, usually the keyboard. And then system.out is the standard output object. So that is where the data goes out, okay, that you want to print to the console typically, okay, which is a window that pops up, a program that pops up on the monitor or down in our output inside this IDE, this Java IDE. So we're going to ask them to enter their age. So we're going to say age equals, and then keyboard dot next int, okay. They type in their age, hit enter, and then we can make a decision based on their age. Just to get this working, though, let's use some sequential statements and just repeat the age next to them. Or back to them, rather, sorry. Your age is, and then we're going to concatenate age. All right. Let's just run this and see what happens to start off. Okay. Waiting on it to compile. It says, please enter your age. I'm going to let's put 20 and see what happens. Let's say your age is 20. Okay, let's run it again and make sure it works still. Okay, we'll say 33. It'll say your age is 33. Okay, so we've shown that it does input the age correctly, but all of this is sequential at this point. Everything's executed in the order that they are written. So we create an age variable. We declare this age variable as an int, and then assign it its initial value or initialize it to 0. We then create a scanner object, and then say equals new scanner based on system.in to get keyboard from input from the keyboard. And then we ask the user, what is your age, basically, and then they type in their age, hit enter, and then the program echoes their age back to them. So a little bit of review here. If you'll recall, there are 8 primitive types in Java. So I'm going to keep drilling you with this so that you will commit them to memory, hopefully, and that you will be able to easily tell the difference between a primitive type and a reference type. Okay, so the 8 primitive types, again, are byte, short, int, long. Those are all integer or integral types. Don't worry when you hear the term integral type. It means nothing about calculus, so if you don't like calculus or more advanced maths, you won't really have a big problem with it. So it's byte, short, int, long. Those are the 4 in order of smallest to largest. Byte, short, int, long. So that's 4 out of the 8. Then you've got 2 real number types, float, double. And then you've got the two types left over. You've got char, which is a character type, and then you've got boolean, which is either true or false. So those are the 8 primitives. Anything that's not one of the 8 primitives is a reference type. So anything such as keyboard, our scanner type here, since this scanner is not one of the 8 primitives, we know that this is a reference type. So when we say scanner keyboard, we're giving the variable an identifier of keyboard. It is of type scanner. So we know that it does not hold the value directly. Remember, if it's not a primitive, it doesn't hold the value directly. It holds an address in memory of that value of the object. Okay, so when we create this scanner here in memory, it's a lot more complicated than, say, an integer or a double or whatever. So this stuff is created on the type of the area of memory called the heap with the new keyword. It creates this new scanner, returns the address. Keyboard now holds the address, and now we can use it. Okay, so again, 8 primitives, anything that's not one of the 8 primitives is a reference type. Okay, very easy. So back to our original discussion, control structures. So what do we do with this age? What can we do with age to make it not go directly and sequentially through the file here and just execute the instructions kind of in a boring fashion? It's not really doing anything interesting. Well, our first, remember the 3 categories, sequential, selection, and repetition. We can use a selection control statement to change the order here, make it do something else. Okay, well, actually, I'm going to leave that. Undid that, so it will say your age is regardless. So that will be in sequence. But let's put our first statement here, an if statement. If the age is greater than or equal to 21, we could say, system.out.println, here, have a drink. So in the United States, I don't know where you're watching this from, but in the United States, 21 is the age where people can drink alcoholic beverages or adult beverages. So we will say if the age is greater than or equal to 21, we'll just print out here, have a drink. Otherwise, we won't do anything. We won't print out anything special. So regardless, though, we go back to sequential statements, and it says your age is whatever. So if I run this now, okay, it'll say, please enter your age. If I put 25, it'll say, here, have a drink. And it'll say, your age is 25. If I run it again and say 19, it'll just say, your age is 19. Well, what happened to the here, have a drink? Well, we have this selection control statement here where it either selects to do whatever's in the body of it or not. Now, as a note, you could, if it's just one line that the if statement applies to, you don't really need these curly braces, okay? But I highly recommend always using curly braces, okay, because it can get confusing. Because if I lined this up here, if I line this up, delete a bunch of stuff, and then tab it over, if we look at this, it looks very much like both of these belong to this if statement right here. But that is not the case. Since an if statement is only, without curly braces, is only good for the next line, or it only applies to the next line, this is the only line that it applies to. The other one, the one below it, even though it's tabbed in the same indentation level, it does not belong in the if statement. It actually would more correctly belong here, or maybe even with some extra space. So to avoid ambiguity, I highly recommend putting curly braces, okay, around it, even if it's just one line, because you might go back and add stuff, and then you might forget to put the curly braces in, and it can cause all kinds of havoc. So, what other options do we have? So let's say I want it to say something special if their age is over or equal to, greater than or equal to 21, but I also want to do something if it's not, okay? So if their age is greater than or equal to 21, I print out here, have a drink. Now here's where we get to our second selection control structure, selection control statement. So we've got else. We want to put else, and then it gets a body also. We'll say system.out.println. Here, have a Coca-Cola. Okay, not a Coca-Cola, but a Coca-Cola. So this right here is our second decision control statement. We consider this a separate one because it, instead of doing something or not, now it's doing something based on a condition, or if the condition is false, we do something else. So we can determine which one gets executed based on the statement, the condition. So if the age is greater than or equal to 21, we print out, here, have a drink. If we test the age and this statement right here is false, then it will go to the else block. Okay? So if this right here is false, it will go to the else block. If it's true, then we will go here. So let's test it out and see what happens. So now if I put 25, it'll still do what it did before. Here, have a drink, and it'll say your age is 25. Notice it skips over this else. So that is not in sequence. If it were totally in sequence, we would look at this and say, oh, we'll print that, okay, print that, and then print that. That would be totally in sequence. But that's not how this works. This branches, okay? Sometimes it's called a branching control structure. So it's decision control structure is another name for it, or selection, because you're selecting among different possibilities. What we have here, though, is it prints out the here, have a drink, skips what's in the else, because it's already satisfied this condition right here, and already satisfied the chain of if-else. And then down here, it always prints your age is whatever, because this is back into sequence. Okay, so we have a combination of sequence or sequential statements. We have the selection statements here, and then another statement in sequence down here. So let's see what happens if we put a younger age than 21, so 19. Now it says, here, have a Coca-Cola. Your age is 19. So here, when we entered 19, that was stored in the variable age. Age was compared to 21 using greater than or equal to. And then since 19 greater than or equal to 21 returns false, since that's false, we do not execute what's in this if statement. It's false, so it picks this alternative down here. So it's one or the other. It will select one or the other. So we have a bunch of possibilities here because we can actually chain these. So if I said something like this, if I said else if age greater than or equal to 18, we could say here, have a Coca-Cola, and then also we might be able to say something like at least you can vote, okay, as a maybe a consolation prize. And then later down here we have an else, and we'll say something like this. We'll say, okay, if they get to this point, we know that this is false, so that means it's going to test the next one. And it'll say, oh, okay, well, if this one's false, it'll go down here. So if it's not greater than or equal to 21, it'll test here. If it's still not greater than or equal to 18, it'll go down here, and this will be the default. It doesn't matter what age you put. So print line will say, here, have a yoo-hoo. Okay, so just so we can distinguish between these. These don't really have any significant meanings to them. We're just showing that it will make a decision between the different sections. So let's run this now. So 22, here, have a drink, your age is 22. 19, oops, sorry, 19. Here, have a Coca-Cola, at least you can vote. And then what if they're, say, 16? 16. Here, have a yoo-hoo. Your age is 16. So, the next thing is that we should at least realize here is that this is really just if-else statements combined. What's actually going on here is this if actually, remember how I said that each if statement affects the line immediately after it if you don't use curly braces? Well, an else statement does too. So what's really going on here is a little more complicated than what meets the eye. So this is actually what's happening. What happens is that if this is false, if the age is greater than or equal to 21, and that's false, Then it goes to the else. Well, what's in the else? This whole thing. Well, that's not a single statement, but since it's a statement that's chained together using this if statement, it will do the if statement test first. So this is basically nested inside of this else. Okay, so if it says if age greater than or equal to 18, we have another set of if else's here. Okay, most programmers, when they use a chain like this, they don't write it the way I just had it. They usually write it closer to this. Okay, because it's just a little bit cleaner. It takes less upkeep, and it just looks a little bit nicer. So people tend to think of this as one long chain of possibilities, when really what's going on is that this only affects the line after it. You could technically put a curly brace here and another one there if you wanted to, or down here. Okay, so actually you'd have to put, if you put a curly brace there, you'd have to put another one down there, and then this part would actually belong to the block of this else. Okay, and you can keep going. I can put another else here and say if they're greater than or equal to 16, here have a yoo-hoo, but at least you can drive, or something like that. So there's all kinds of different options here. Now we have to be careful here because the order does matter. Let's say I put age greater than or equal to 18 up here. Well, let's see what happens if I switch these. 18 and then 21 down here. See if we get any problems. Into your age. Let's say 22. Okay. Oops. Well, I think I should, yeah, well, okay, we'll look at it. Here, have a drink. Your age is 22. Okay, that seems pretty reasonable. What about this, though? Let's say 19. Well, that's under the drinking age. So 19, let's say, here, have a drink. Your age is 19. That's weird. Well, what's happening is it's testing this. And it tests this, rather, age greater than or equal to 18. Since that's true, it prints out this line, and then it skips anything else in its chain. Okay? So you have to be very careful. The order does matter. Okay? So since this does satisfy 19, it will never get to test this one. Okay, so let's switch those back. So we'll say this is back to 21, and this one's 18. So you have to think logically. If this one is ever satisfied, it'll never get to this one down here. And if this one is always going to be satisfied, if this one is, then it'll never get here. Okay, it may eventually get to the else, depending on what the situation is, but it'll never actually get to this 18 here. Okay, so you got to be very careful. So that's if and if else. All right, let's make another control structure file. Okay, we'll say control structure fun2. We'll make our little main here, public static void main, string bracket args. So inside of here, we're going to at least look at the final option we have for the selection control statement. So remember, 3 categories: sequential, selection, and repetition. But we've also got selection and repetition subdivided. Remember, selection is divided into if else, and switch. And repetition is divided into while, do while, and for. We already covered the selection, 2 of the selections, so if and if else. Let's look at switch. Switch is very good for when you have multiple choices, multiple options to choose among. Now, you can always simulate it and do the exact same thing with a bunch of if-else statements. Probably, I'd say, maybe 15% of my code that has to use selection control statements use switch, and the other 85% use the if and if else structures. But you're always welcome to use switch if it makes sense to do so. So let's do something very similar here. So I'm going to say int let's not go with age. Let's go with we'll say employee ID. Okay. So we're going to also import Java util.scanner, so we can get input from the keyboard again. Create ourselves a scanner here. Keyboard equals new scanner. Then I'm going to print out, regardless, I'll say your ID is, and then print out employee ID somewhere near the bottom. But I also want to ask them to enter their employee ID. So enter your employee ID. When they enter their employee ID, I'll say employee ID equals keyboard dot next int. Okay, and once we get that value, let's say there are a couple special employees. Maybe there's 100 means the CEO, or 200 means a manager or something like that. So we'll put a switch statement here. We'll switch on the employee ID. Okay, that's the end of the switch statement here. We're going to switch on the employee ID, and if it's the case that the employee ID is equal to 100, then we're going to say system.out.println welcome CEO. Welcome CEO Murphy. Okay, and then we have to break. Okay, the break statement tells it, don't try to test the remaining stuff, just get out of this switch statement. We found something that satisfies it. So case 200, we'll say system.out.println. We'll say welcome Director Robinson. Okay, then break also, and then default is kind of like an else dangling at the end. It just means if it's not 100 or 200 or anything else above me, then this is the default. Okay, we'll say welcome employee, and then break is technically not required, but a lot of people put it there at the end. So let's see what happens when we interact with this program. So enter the employee ID. Let's say I'm 100. It'll say welcome CEO Murphy. Your ID is 100. If I run it again, let's say I put 200. It'll say welcome Director Robinson. Your ID is 200. What about if I put my employee ID is 122? It'll say welcome employee, because that's the default. The other two did not satisfy it. So these are really good for when you have specific values. Maybe if you're writing a video game and you have to detect if they're pressing the up, down, left, or right arrow for movement, or WASD or what have you for movement, then that would be very, very good to put in a switch statement, because they're very, very specific, discrete values. Switch statements are not very good with things like ranges compared to their cousin, the if statement, or the if-else statements, but they do work in certain scenarios. So you can use these when you have very, very specific values, and then if you want to just have a catch-all at the end, then you can put the default there. So I find these are sometimes very useful, especially if you have a string of very, very specific things, like I indicated before, like up, down, left, right, north, south, east, west, grades A, B, C, D, E, F, G, A, B, C, D, E, F. G is not a grade yet, although I think some of my students want to get that grade because they try really hard. Okay, so control structure fun, that's our second one, and we are good with that. Let's try repetition control statements now. So Java class, we're going to call this one repetition fun. Okay, repetition fun. And this one I won't really need input, I don't think, for right now. Public static void main, string args. Okay. So I'm going to create a counter. This is going to be what we call a counter-controlled loop. So like our friends, the if statement, the if else, and even the switch, there is a some sort of condition or some sort of thing that's being tested, but it does something differently with a repetition control statement. So with selection control statements, it's deciding among or between different options. Okay, it either does one thing or it doesn't do anything, or it does one thing or another thing. So it decides among different options based on a condition. with a repetition or iterative control statement, also known as a loop, it will continue doing something as long as a condition's true, not deciding to do it or not. It will do, not in one fell swoop. It won't just do one section of code or another and then be done. It'll keep going as long as a certain statement is true. So what I'm going to do with this is I'm going to use the first repetition control statement we're going to be introduced to. That is the while loop. So I'll say while counter is less than 10. Okay. And while. So right here we have while the counter is less than 10, I want to print out system.out.println. I'm going to say counter is, and then just print out whatever value counters is. We have to increment or increase the value of counter, so I'm going to show you a little shortcut here. You write counter plus plus. Okay, that's the same as if I said counter should get assigned the value of counter plus 1. So it's basically a shortcut because this is very tedious to write and this is very simple. So you just add 1 to the counter each time through the loop. Let's see what happens. Wow, that was pretty fast. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So it goes through the loop. So the first time through the loop it says, since counter was initialized to 0, it says, is 0 less than 10? Since that's true, it goes in here and starts printing out this. It says counter is 0. Then it increments counter to 1. The next time through the loop, it'll go back up to the top. Is 1 less than 10? Yes. So it prints out the 1. Is 2 less than 10? 3, 4, 5, 6, 7, 8, 9. When it gets to the 9, is 9 less than 10? Yes, counter is 9. Counter plus plus, that counter then becomes 10. So it goes up to the top again to test. It says, is 10 less than 10? Since 10 is not less than 10, that is false, it will break out of the loop and then do whatever's under here. So we could put another statement here just to say something like done with loop. Okay? So run file. So it'll say done with loop after it gets done with that. So we've looked at a couple different symbols here. We've got the less than, but you should also know there's a variety of these types of comparison symbols. Okay, so these are called relational operators because they relate to different values, and the ones that we have at our disposal are the greater than, less than, greater than or equal to. Since we don't have a symbol on the keyboard to do the mathematical symbol that looks like this, it's easier to just type the less than and then an equal sign, so that's what they decided to do. So you've got greater than, less than, greater than or equal to, less than or equal to. Then you've got, some people break these out into a separate category. I tend to think they're pretty much the same category. You have the not equal to and is equal to. Okay, the equality operator and the inequality operator, not equal to operator. Okay, so just keep in mind you have all of these at your disposal when you're doing the selection control statements or the repetition control statements. So that's a while loop. Let's see another example. I'm going to save this guy, and we're going to go here. We're going to call this repetition fun 2. In this example, we're going to public statement void main, see one of the while loops cousins or siblings, whatever you'd prefer. This one's going to show you the do while loop. Now do while, let's say it counter is equal to 5. Okay, we'll say it's 5 just for the purpose of demonstration. So while counter is less than 5, and inside here we're going to print out just in the loop. Okay. So you might think, well, how's this going to ever go through the loop? Because this statement right here is false. Now, another thing to note is that there is a semicolon at the end. This is the only loop that requires a semicolon after the end of its little condition statement here. Okay, the loop termination condition or loop continuation condition is being tested right here. So it does require the semicolon. That's actually one of the ways that the compiler can distinguish between a regular old while loop and a do while loop, is the fact that you put a semicolon after this guy. So right here you have do, and anything you say to do will be done, and then the loop continuation statement is tested. So this is a little bit different. The while loop tested before it went into the body of the loop, before it did anything. The do while loop is like the reckless little brother, and of the other two. We'll get to the for in a second, but while and for are pre-test. They do tests first and then see if they want to jump in the water. Do does whatever's in its body and then does the test. So basically, do it now, ask questions later. So even though this statement is false, the do while loop is guaranteed to execute at least once. Okay, so if the statement was true, it acts pretty much like a while loop, exactly like a while loop. But with a do while loop, it is guaranteed to execute at least once. Okay, so let's run this. Okay, so it just says in the loop. It doesn't print it more than once. It doesn't do it a bunch of times. It does it only once because when it gets here, then it gets to here and tests the statement, and it says, oh, that's false, so I got to break out. Another thing you got to be careful with is a lot of people forget this. So let's say counter plus plus, and I want to initialize this to 0 instead. Let's see what happens. So in the loop, in the loop, in the loop, in the loop, in the loop. So it does it 5 times as we expect. If you don't have this statement there and you initialize the counter to 0, you're going to get what's called an infinite loop. And that's going to be a very, very, very big problem. So if I comment out the counter being incremented and I run it, you'll see it looks like it's just still, but it's not, because this is growing and growing and growing all the time. So I'm going to actually kill it because it's actually taking up a lot of processor time. I had to actually terminate it manually. So you'll see it's just printed out in the loop just dozens and dozens and hundreds of times. Okay, several hundred times, probably. Yeah, multiple hundreds, probably a couple hundred times. So that's very bad. We don't want that scenario. So you got to know to make sure that you move towards termination of the loop. You never want to leave it so that it's never changing. So that if you don't increment the counter here inside the loop, it's going to just remain 0, and then 0 less than 5 is always going to be true. It'll say, is 0 less than 5? Yes. Okay, we'll keep doing it in the loop. Is 0 less than 5? Yes. Okay, keep doing it in the loop. 0 less than 5? That's called an infinite loop. Now, it technically won't go on for infinity. We know that, but in theory, with no limits of anyone interacting with it, and no limit or constraint on the program crashing or taking up too much memory eventually, then it would go on for infinity because it has no way of knowing to stop. So that's the second repetition control statement. We're going to save that. And then our final one, we're at the home stretch, folks. Repetition fun 3. So this right here is going to be our friend the for loop. Okay, now the for loop is very good for counter-controlled repetition. There is another kind of repetition. We generally classify them as counter-controlled or sentinel-controlled, and we'll get to that once we get into file input-output. That's when there's a special value that it waits for rather than a specific number that it needs to count up to. That's why counter-controlled repetition is called definite repetition, because we know how many times it's going to go a specific number, a definite number. But if we don't know the number of times, let's say we ask the teacher, enter another grade, or -1 to exit, or whatever, and they keep entering grades, we don't know if they're going to enter 10 or 50 or 70. So that's called sentinel-controlled or indefinite repetition. But we'll get to that a little bit later in the course, not this particular lesson. We'll deal pretty much all with counter-controlled repetition this time. But I did want to make that mention so you know that there are two kind of categorizations of ways to use the while, the do while, and the for. Now the for loop in some ways is like its brother, the while loop. It does do a pretest. It is a pretest loop, so it isn't careless like the do while loop, its other brother. But it does stuff all of everything it needs to run the loop in the header of the loop, rather than having to remember to put an increment statement, for example, inside the body. You put it up at the top. So everything here, int I equals 0 is only executed once. The comparison is done each time through the loop, and the increment is done each time through the loop. So here I can say system.out.println, and then we'll say number is I. If I run this guy, number is 0, number is 1, number is 2, all the way to 9. So this is perfect because we don't have to remember to put the counter inside the loop. Now you might ask, well, why am I using I instead of counter? You can name it whatever you want. You can name it counter, sausage, horse, cow, donkey, it doesn't matter. You can name the variable as long as you're consistent between these three. You can name this control variable anything you want. However, it is customary in a for loop, much of the time people will use single letters like I, J, and K, and people just kind of automatically assume that's, okay, I is the outermost, and if you have another loop inside the loop, you're probably using J, etc. So I is the most commonly used variable with for loops. But just to show you it works, I could put counter here. I would then have to put counter there, and then I could put counter there, and then finally counter there, and it will still work. So I run this guy, it does exactly the same thing, nothing has been altered. Alright, so that's the for loop. So we've covered, again, let's do a quick review before we call it a day. You've got three categories of control structures. Remember, control structures and control statements have to do with changing or modifying the flow of control through a program. The three categories are sequential, selection, and repetition. Sequential is the default. Again, that means going line by line and executing it in the order that it's written. Selection, which is the second category, means that you are deciding among different alternatives, or doing something or not, as is the case with the regular if statement. Then you've got repetition. Repetition means to continue doing something as long as a condition is true, what we call the loop continuation statement. So we've got the three categories, and then remember, sequential is just sequential, there's no subdivision. And then selection control statements, there are three different statements that are in this category. You've got if else, and switch. So if is good for do we do it or not, else is we do this or that, and then you can chain the if else to do this or that or that or that or that. And then switch is really good for multiple selection multiple selections if you have specific discrete values that you're dealing with. And finally, repetition or iteration, that category has three also. While, do while, and for. Now some of you, if you're experienced with Java, might say, well, what about the enhanced for loop? Well, we're not there yet, but I still consider that a for loop. It's just what we call syntactic sugar. It just makes it look a little bit prettier, and it does slightly different behavior, but it really is just another for loop. You could say there's for, but usually we just go with, I just say there are three repetition or iteration control statements. So while, do while, and for. While and for are pre-test, so they do the test and then they decide whether they do what's in their body. Do while, again, the reckless younger brother. It just jumps in and then asks questions later, right? It executes whatever's in its body at least once. It's guaranteed. Even if the statement were to be false going into the loop, it is guaranteed it will do that. And then it checks the statement afterwards. Other than that, it works exactly the same as while or for would. So that's pretty much what I have for you today. I hope this lesson was very useful. I know it was a little bit longer, but this is a huge, huge topic in any programming language, and especially for where we're moving forward in Java. So you've basically got the three categories, and the categories broken down. So I'll see you next time on the Computer Science Channel.